Thank you to everyone for joining our webinar today. My name is George Nemi. I am the Juniper Solution Specialist here at Bytespeed. Very excited for our speaker today. It's Jess Ward from the Mist team at Juniper. We've been partnered with Juniper for about 8 years now, and we're very proud of the deployments we've done with them. If at any point you have any questions, please use the Q&A button on your screen, and we will address those periodically throughout the webinar. Without further ado, take it away, Mr. Jess.
All right. Well, thank you, George, and appreciate the opportunity to talk to everyone on the call today. So my name is Jess Ward. I'm the area VP for the Mist side of Juniper. So I'm responsible for the eastern half of the US. So basically that's the Midwest on over to the eastern seaboard. I've got 12 different teams, and we're the specialist group within Juniper focused on what we call AIDE, the AI-driven enterprise. And what we'll do today is just talk a little bit about some of those key differentiators, some of our momentum in the market, what customers are responding to, what's driving our growth. I think we'll be able to take a few questions after I do just a handful of slides, and then go in and actually show you the product, show you the demo, show you where the key things are that have given us momentum in this space and what customers have responded to. So I'm going to share my screen. And if all goes well, we should see this presentation come up, and put in presentation mode. All right, so I'm going to assume everyone can see this, and just let me know, George, if not.
Looks good on my screen, Jess.
Perfect. All right, so what we, this is the unicorn of networking, and what I try to call, here's my unicorn just for evidence. I really like to think of our AI engine as basically a member of your IT team. In football seasons, was winding up, but at the beginning of football season, I kind of coined it as the 12th man, an invaluable assistant to the team here that just helps support everything that IT does, all about the user, improving and maintaining a good user experience. That's really what we're about at Mist. It's what the AI engine is designed to do. So again, in this call, just what I thought I'd briefly do is talk a little bit about the story of Mist within Juniper, how Mist got started, the acquisition by Juniper, and what we've been doing since. Talk a little bit about what the customers have responded to. That's both within the product and the solution and our approach to delivering this type of service. Talk about Marvis itself. So what the personification of our AI engine, what are the key things it does? How does it solve problems? How does it help IT? How does it help your users? And mention we'll take a little break there, talk, see if there's any questions that I can answer, and then jump in, actually show you the live demo. And then we'll talk about some next steps you can take if you want to get more information, you want to get a free AP. All of those things are part of an opportunity everyone on this call is going to have. So with that in mind, I usually like to give a little bit of the context of where Mist started. And if you look at Mist came from the team that was running all of the Cisco wireless switching and routing business unit. And it really comes down to primarily a guy named Bob Friday. So Bob's very well known in the wireless space. He actually invented the first wireless LAN controller with a company he founded called Airspace. Cisco had acquired Airspace. Bob came over with that acquisition, and it's still the dominant architecture that Cisco sells today for wireless is based off the Airspace technology that Bob invented, controller based. Bob was also on the team that wrote the check and acquired Meraki so that Cisco could have an SME play using a cloud-based solution. And what we've seen from Cisco is that's kind of, they're trying to morph between the two. But I say that just to give you some context that the team that built Mist did it because they felt like they were constrained within Cisco in terms of how they could build a next generation solution for the next decade approach. And that was really what Bob felt like he needed to leave Cisco to do. In his analysis of the market and his analysis of every customer he had spoken to at Cisco, there was a need for something that was really focused on the user experience, and a way to quantify the only two issues you have in wireless in particular is I can't connect and the wireless thinks. That's it. So Bob's vision was to collect enough data and leverage AI and to interpret that data so you could answer those two questions within the system itself. Take all that burden away from an IT staff and improve the user experience. That was kind of the genesis of Mist. So he left. Sujay Ajela was running that business unit within Cisco. So they both left and they founded Mist with that in mind: disrupt the industry with a data-driven, AI-based approach and deliver outcomes you couldn't get from any other solution on the planet. So that's really where Mist started. And if you look at kind of where we are, there should hopefully be a new Gartner Magic Quadrant released very soon. But you can see in that time since Bob's vision of building a new company to what we've done through the acquisition, through Gartner's Magic Quadrant, top right leader, past everybody, folks that have been in the industry for 20 plus years, we've catapulted. So it's a validation, I think, of two things. One is we're doing something that's uniquely valuable in the market. It's being recognized by customers and partners. And there's been a lack of innovation from everyone else that's been in this space. They're stuck in old architectures, stuck with the limitations, and the freedom that Mist had to build something from a clean sheet of paper really allowed us to accelerate through and deliver outcomes you couldn't get from any other solution. So we're proud of the industry recognition, and to give that a little more context, so you can kind of see where this journey began. In 2018, both Mist and Juniper were separate companies. Mist we were a startup that was wireless only, focused on AI to make wireless problems easier to solve and resolve and happier users. And Juniper was still working through an enterprise networking strategy, frankly, at the time. Juniper very astutely realized that Mist had something special. Special not just because it would fill a wireless portfolio gap within Juniper, but that this AI engine is something that could be applied to the rest of the Juniper stack. And that became the real interesting piece of the acquisition. So in 2019, we came together, and you can see kind of an immediate move to the right in terms of vision. The market reacted. This was something that could be very interesting with all of Juniper's legacy and powerful networking technology, with a next generation cloud architecture that was AI based. Putting those two things together would be very disruptive to the industry in a positive way. And then we started to get the acceleration. So these were larger and larger customers were adopting this, and Juniper was making its name now as a leader in enterprise networking based off the strength of this AI approach. So that just gives a little context. Nobody's made a move like this in a Gartner Magic Quadrant in such a short amount of time. So we're proud of it. It's some validation, but this came primarily through customer feedback to Gartner. So if you look, one of the other aspects that we have of Bob's vision is location-based solution. So Bob invented a Bluetooth antenna array, the 16-element antenna array, fits right on every single wireless access point. So that infrastructure is already there to support very precise location-based services if you choose to turn it on. We get a lot of this in K through 12 and higher ed and healthcare and retail, where they want to know where people or devices are in a building, those sorts of things. So that's also been recognized. We're the only vendor to be a leader in both quadrants here for indoor location-based services and wired and wireless. So the point of that is really to say we are looking to add unique value across different lines of business or different departments within any organization. We don't want to just be the best wired and wireless solution out there. We want to provide unique other benefits that we can do, leveraging this architecture, leveraging this technology, so that we can solve more problems. We want to be a strategic partner, solving as many problems as we can for all of our customers. So this gives you that recognition. But I'd say this is probably what we're the most proud of. And this is really customer feedback, where we've had customers talk to us and say, these are the outcomes they've achieved since moving to Juniper Mist. And this is probably the most impactful thing that we can really talk about. Because if you look at every one of these logos, making a decision to migrate from whatever they were using in the past to a Juniper Mist solution was a big deal. Lots of people involved. And people were making, bets essentially that we could do what we said. And the greatest, most gratifying thing about this type of feedback is every one of these organizations that took that risk to make an incumbency change to Juniper Mist were rewarded handsomely. And we delivered over and above what they could get from any other solution out there. So it was a really big win for them. It was a great win for us. These are the types of things that have built our market momentum. But you can kind of see there's basically about 3 generic outcomes you could expect anytime you move to Juniper Mist. You're going to get dramatically less trouble tickets related to wired and wireless. You're going to get dramatically less time to resolution of a ticket that does come in because the data is there. And you're going to get a very quick speed in terms of deployment. For wireless in particular, this is not necessarily a technology benefit, but we're happy to have it, is we can ship APs within a couple weeks. So in this world of supply chain, the AP delivery itself has allowed us to really help customers meet deployment timeframes. So not a technology thing. Our technology aspects there are really around things like zero touch provisioning, template-based configuration of wired and wireless and those sorts of things. But it's nice to have the shortest lead times in the industry as well. So if you look at kind of the key things that we do that are different, I've talked a lot about AI, I've talked about data, I've talked about analytics, but it's really about how we measure each individual client's experience getting on the network. This was a problem that Bob was trying to solve at Cisco and just couldn't. He didn't have the right architecture of the data at Meraki. That was more of an easy configuration tool, not a great analytics tool. He had a lot of data on Cisco, but it required things like DNA and on-prem devices. There were limitations there, subscriptions. He did not have what he needed to give what he wanted, which is he wanted anyone to be able to go in and find out how's the user experience at any point in time. Today, yesterday, right now, so that we can quantify those two statements. If I can't connect and the wireless stinks, we want to know why and how to fix it. That requires the kind of data that we collect around client experience. So for example, on the wireless side, we collect 150 states for every client every minute. That data is coming into the Mist cloud. And that data is what the AI engine is designed to do. AI for Mist was always in the product. It was always a vision of Bob's, not a marketing term or something you add on later to old architectures. It was built for AI because you need an intelligence algorithm and piece there to take all that data that's coming in, contextualize it, make it actionable, look for trends, look for anomalies. That's what an AI engine does. Instead of having a team of network experts here, it's all built into the product. Everywhere you have a Mist wireless access point deployed, for example, it's like having a network engineer there, looking at all the information and making decisions and telling the cloud. So really, that's a key aspect of where the AI comes into play. It's analyzing the data that's coming in from all these sources. Other key part that Bob wanted to do from a clean sheet of paper is build a microservices cloud architecture. So this is a modern cloud architecture. This is what Netflix and LinkedIn and everyone uses. And the concept behind it and the key outcomes a customer gets from this architecture is we can innovate very quickly. Microservices basically means every function of our system is its own microservice. So if there's a bug, it's contained just to that microservice. It's not pervasive across what used to be a controller or single operating system. You don't have that limitation. You full flexibility. If you want to add a new feature, you add it just to that microservice. It doesn't have to be regression tested like a single operating system would have to. So basically that means we can fix things quickly. We can add new things quickly. And the net result to our customers every 2 weeks, we do some kind of a cloud optimization. We add features, we make fixes, and we do that as completely hitless to the customer so that the solution is constantly improving. The worst the solution will ever be is the first day you deploy it. It's only going to get better. Every 2 weeks, because of this architecture, we can continuously improve the cloud side. And then I mentioned location. It's there, it's built in. You'd be surprised with the number of use cases you can solve for with location-based services, and whether that's a primary project you're working on or kind of, okay, it's nice that it's there because I'll probably use it later. Either one of those things are really a valid approach to what we're trying to do here, which is provide a solution that solves as many issues as possible, whether it's location-based or just connectivity, wired or wireless. So the Juniper acquisition, I mentioned this before, it's really about the Juniper's acquisition of Mist was about the cloud and AI architecture. And you can see here the purpose is to be able, if you had a full stack from Juniper, is give a full client to cloud experience. So if we have the data related to the wireless access points and Juniper switching and Juniper SD-WAN, we can tell you the entire path of the user all the way from their connectivity to the network through the applications out to the cloud. So that's really allowed Juniper to present a full stack that's you could say 1 + 1 = 5. 1 + 1 + 1 = 5 if you do all three. The idea here is a consistent data platform and AI across every aspect of that customer journey will provide visibility you can't get from anyone else. Now, most of our customers in reality don't usually buy all three pieces at one time. Budgets are different, cycles are different, et cetera. So we may start with the wireless. A lot of those customer logos you saw, we started with wireless. That was the first entry point, the first thing they needed to solve for. But they saw very quickly, once you have the Mist AI cloud in place, as you add more pieces of the Juniper portfolio underneath it, you start to get more and more value because of the data, because of the consistent visibility we have from the client through the cloud. So keep that in mind. There's each one on its own, runs incredibly well, still has an AI engine. But the beauty is, as you stack them together, everything becomes, exponentially better. And that's really what's driven a lot of Juniper's growth there from the enterprise networking perspective. I usually like to take a minute and actually show, what are the components of this solution, just so everyone's clear what we do and what are the different aspects offered. So of course, at the top, this is the Juniper Mist Cloud. This is doing all the AI. This is the microservices. This is where all the magic's happening. But from a devices that you would physically go out and deploy, all the different wireless access points are here. I will take a minute to talk about this thing in the bottom left here. That's called the Mist Edge. So a lot of our customers run in that traditional controller-based model that Bob built 20 years ago. It's just how they've deployed it. It's what they've been doing. They tunnel traffic to a single controller, put their policy enforcement and VLANs behind the controller, not at the edge. And that's fine. A lot of folks have designed for that, and that's the way they want to move forward. So what the Mist Edge box is designed to do is, if you're running in that architecture, where it's a traditional controller architecture, APs forward traffic to the controller, and the controller is the data path going forward. You can do the same thing with us. If you don't want to redesign that, you would just drop that Mist Edge box wherever you have controllers doing that centralized data forwarding, and you're good. You're done. The Mist Edge box, just like our access points and our switches and SD-WAN, it's all plug and play. So you just drop the box in there, it talks to the cloud, pulls a configuration. But the point of that was, we didn't want anybody to miss out on all the goodness of our AI because they were using a traditional controller architecture. So the Mist Edge solves that problem. We drop in wherever you have controllers. Now you get all the goodness of our AI without having to re-architect the network. Certainly not required. A lot of our customers do local forwarding right from the AP to the switch. VLANs are at the switch level, and that's where the traffic goes. So we can do either way. I usually like to point that out just to make sure that we don't get lumped in with cloud-based networking solutions that might not bode well for folks running controllers today. On the switches, you can see all the different switch models here, zero touch provisioning. A quick story on the switches is really that the Junos operating system, what Juniper's really built their networking platforms on, this very powerful Junos operating system, runs on every one of these switches. What we've been able to do with the mystification of a Juniper switch is give you the power of that Junos operating system, but present it through a UI, present it through a cloud-based, easy to see, easy to understand, template-based configuration. So I don't have to know any Junos command line stuff, but I still get the power of the Junos operating system on the switch, because we can put all the configuration and data analytics behind this cloud. So I can point and click just like with any other cloud solution, but I still get this incredibly powerful operating system running on all the switches that are deployed. Zero touch, provisioning, new switches comes online, talks to the cloud, pulls a config, once a template's built, all those things. So again, it's really accelerated Juniper's play in the enterprise networking segment, because people wanted both. They wanted the full-blown enterprise-grade functionality of a Juniper switch, and they wanted the ease of use and zero touch, and I don't want to know command line. I just want to be able to point and click to build everything, even including fancy fabric type architecture like EVPN, VXLAN. That's all built into the UI. You can build the entire fabric right in the UI without ever having to do a command line. It's been powerful. And then of course with the SD-WAN component, now we're getting that visibility through the cloud and through the application side. So again, any one of these three can sit on their own and work incredibly well with an AI engine. When you start putting them together, you start to see that the power is exponential. One or two more pieces quickly, and then I'll jump into the demo as promised. But We talk about Marvis. Marvis is basically our name for the AI engine that's sitting behind the scenes, that's doing this analytics, doing all the analysis, and presenting it in the UI to do those things. Dramatically reduce trouble tickets, dramatically reduce time to resolution of a ticket that does come in, dramatically reduce the time to deploy, those sorts of things. So you'll hear Marvis a lot. That's really just the name of our AI engine. But data is really the differentiator. When Bob built this company to disrupt this industry that's 20 years old, he knew it needed to be data was the key way to differentiate. So what you're seeing is all this data is coming into the Mist cloud. It's metadata. It's not full packets. It's not anything that would impact your WAN, but it's a lot of data. 150 states for every single client every minute. That metadata is going into the Mist cloud. So that that data runs through AI primitives. You'll see this in the demo. We can group that data based off AI, and we can contextualize it so you can see, okay, the data that's coming in is related to this issue for this user at this time, and here's what I need to do to fix it. That's what the AI engine is doing. Data science, the middle piece here, it really allows for a very advanced thing, but a very powerful aspect of the solution is anomaly detection. So what anomaly detection allows you to do is ideally get ahead of an issue. We can see how your network is normally behaving, and then we look for meaningful deviations from that behavior. And when we see a meaningful deviation, we flag it, we alert on it and say, here's something that's happening. DHCP is taking longer than usual, radius, those sorts of things. And we believe it could impact your users. So here we want to let you know about it is really what the system is doing. So anomaly detection is an implementation of data science that's very powerful. So you can imagine some of those logos, the tens of thousands, some of those have 100,000 APs deployed. We can say that in this area, something is trending the wrong way. This is what you need to focus on to fix before a user calls to say it's broken. I'll show you the virtual assistant. So this is another implementation of AI that we have in the system. This is really designed to have somebody who is an IT generalist, not a Wi-Fi expert, not a networking expert, access and get meaningful data from the system just by using natural language. Type a question in and get that data back. Very popular for, think of help desk, folks that are IT generalists, but not necessarily experts in any part of networking. The more we can empower help desk, the less tickets get escalated to level 3 engineers. Everyone's happier. So that's really the power behind it. And then, of course, where we can make things self-driving, we have the data. We can make good decisions with that data, and we can do those things and automate that decision, make the change, and then use reinforcement learning if we make a change to see, did it make it better? Did it stay about the same? Did we make it worse? And take that in as part of the feedback loop. So again, it's all about data. Once you have the data, you can do all these things once it's leveraged the right way. I'll take one quick minute. This is not about data. This is just about hardware. Probably the only time I'll talk about hardware, because it's not really our differentiator, but it is a very powerful from a wireless access point perspective. You probably heard Wi-Fi 6E. That is the next generation for Wi-Fi. And that is a whole new spectrum of access. So FCC unlocked the 6 gigahertz band. New Apple iPad Pros have a 6E clients. You're going to see more and more. There's a lot of Samsung clients, Android clients out there. This will be a very pervasive client in the market because it allows those clients to have a 6E chip. If you're running it on one of these access points, to have an entirely different band, a highway to pass traffic, where traditional access points have a 2.4 gigahertz band and a 5 gigahertz band. Now you have a 6 gigahertz band. So simultaneously, you've got 3 lanes, or I should say 3 highways, all with different lanes running at the same time. And it really helps solve for the number one constraint you have in Wi-Fi is airtime, air congestion, those sorts of things. So if you're going to deploy anyone's wireless solution and you're looking at doing that now, you need to be looking at 6E. It's going to give you the most shelf life, the most investment protection. More and more clients are going to show up, and the more clients that get on 6 gigahertz make life better on the 5 and the 2.4. So with Mist, this is our number one flagship AP. This is what we're shipping today. These are in stock, couple week lead time. But the AP45 is our flagship, most popular. And it is because there's so much flexibility within the radio itself. So you have essentially 4 radios, one that's 2.4 or 5, so it's software definable. So I can make that radio 2.4 or 5, or I can have the system make that adjustment for me automatically. You have a second radio that's 5 gigahertz, a third radio that's 6 gigahertz, and a fourth radio that's scanning across all three bands, 2, 4, 5, and 6. And that gives us more data about the air and environment. That data goes to the Mist cloud for analysis. Very powerful. Just think of it, what I'd like to talk about is if you have a high dense deployment, so maybe it's a school and you've got an AP in every classroom, or it's higher ed, you got a bunch in an auditorium, or it's healthcare and you've got one every 1,500 square feet for voice and all those sorts of things. The power of this AP is you have a lot of flexibility in the radio type. So you could have most of those APs running dual 5 gigahertz and 6 gigahertz, and have every third or fourth AP running 2.4. That 2.4 will give coverage for all those devices, but it also allows any AP that can run a dual 5 and 6. Now you've got 3 bands running simultaneously that don't have the congestion of 2.4. So anyway, it's all something that can be designed for. This is going to give you the most future-proof. It's been our flagship. This is the one that's been most popular, so I thought I'd just take a minute to talk about it from a hardware perspective. I think we're down to the demo, so maybe I'll just take a quick break here and see if there are questions, as I just locked my screen. But anything that I can answer before I jump into the demo?
Well, unfortunately, Jess, it looks like you're doing too good of a job of explaining everything. No questions as of yet, but I'm sure as we get into the demo and you start to show all the bells and whistles, that'll change. So, yep, just a reminder to everybody, if at any point you have a question, please use that Q&A button. We'd be happy to answer them for you.
Well, in that case, let me go back, and I don't think I'm sharing now, Doug, right? So let me share, and I'll get in and show the demo. Hopefully you can see this.
Yep,
I'll
that
clean it
popped
up a
up
bit
for me, so should be good to go.
All right, cool. Well, then, as I said, it disappeared. Hold on. Here we go. All right, so this is a live demo. You never know what you're going to get with a live demo. So let's see what we all find out together here. What I've got is this is our implementation of the Mist solution at our basically at the old Mist headquarters office. And what I thought I would do with the time we have is maybe just show you mostly day 2 sort of things where I think our differentiation is the most profound. You think of day 0, you're building configuration templates. Day 1, we're setting up the zero touch provisioning aspect. They're actually installing. We have an installer app. You can take a picture of it and scan it in, and it reports in. Those are the kind of day 0, day 1 stuff. Very cool, but really what I think of our value uniquely is in the operational side of it after things have been deployed. What are we doing to eliminate tickets and time to resolution on tickets, et cetera. So with that in mind, I want to break this down into a couple operational aspects that are unique to what we do, but add a lot of value. So the first thing we have is something we call service level expectations. This has been in the product for 5 years now. It just continues to be one of the key aspects that customers really gravitate towards, because they want to see how well is the network performing against the goals that they've set. And if we fail to meet one of those goals, I want all the data to understand the who, what, when, where, and why. So that's the purpose of the SLE, service level expectations. So you can see I'm filtered over the last 7 days at this location and looking at wireless. Wireless is more interesting. There's just so many more variables. We get better data from the wireless side. But you can see here, I've got these different metrics, and we're measuring these things to see how well we've done. So essentially what we're doing here under settings is we're setting goals for each one of these aspects. So if I look at time to connect, for example, you can see we have a goal here of 2 seconds. So what this is saying is for us to have a success here, every single client has to be able to connect to the wireless network in under 2 seconds. Connecting into the wireless network, if you're familiar with wireless, is 4 steps. There's an authorization stage that happens on a client that's trying to get to the network, where they get challenged for some credentials. So if you're in an airport or hotel or retail, they hit you with a captive web portal, or it could be strong authentication using 802.1x and ICE and Radius using AD credentials, things like that. Pre-shared key, that's the authorization stage. Once you successfully pass the authorization challenge, then you're associating. So you do an association phase to the wireless. Then you do a DHCP request to get an address And then once you have an IP address, then you try to ARP the default gateway so that you can get out to the internet. Those 4 stages happen on anyone's wireless connectivity. So the purpose behind measuring that is we can say, okay, well, how long is it taking for someone to get through those 4 steps? And we want to measure that and act on it if it's taking longer than 2 seconds. Now, 2 seconds is aggressive. Industry average is 4 seconds. We actually default to 4 seconds because that's the average. We change it to 2 seconds so we can get some more alerts and alarms here for demo purposes. But what we're showing here is 90% of the time at this location over the last 7 days, we have been able to successfully get people on in under 2 seconds. So not bad, but that means 10% of the time we failed. So if I just click into this SLE, you start to see all this data that we're collecting, this example of how it gets organized in a meaningful way. So there's context behind it. There's actionable results behind it. And somebody across a large or small deployment with a small IT staff can get to the data they need to fix, solve problems, and ensure a good user experience. So again, what you're seeing here is we're on the time to connect SLE. These are the 4 stages, and we're measuring each stage to see where we had an issue. Within DHCP, we could see we got unresponsive DHCP server, 97% of those failures, et cetera. So the data starts to give us visibility. And I'll just take you through this from left to right so you have to see how we can organize this. But what we're showing here is all the way from left to right, the timeline. So the timeline is over the last 7 days. These are the different stages in a connection. And here's who failed and here's what time. And then you can see it's linear to the number of connected users and also to anything that happened as a system change. So that's important because maybe somebody came in there and changed the pre-shared key. Now everyone fails the authorization stage that was using the old key. Or they changed something related to the credentials with Radius or a captive web portal. Then maybe a DHCP runs out of IP addresses. You're going to see a spike in this unresponsive failure at this time. So it's all designed to say, okay, from a timeline perspective, I can see when these failures happened. Was it related to a system change or was it just a time of day? And it's a big piece to the puzzle when you're doing analysis. The distribution is very powerful. So now we're the distribution of those 10% of failures in the last 7 days, and we're doing it across different groupings. So here I can see which operating systems did we see failures on. So one of our favorite customer examples is we ran in a very large warehouse, mission critical. We earned our way into the warehouse finally, and it was running great for a couple of weeks. And they called and said, "Oh, the wireless is down." We said, "Okay, let's take a look." And really, they thought all wireless was down. But we very quickly looked into the timeline and we could see, okay, well, the authorizations were failing right after midnight. So immediately we saw a spike right after the timeline said midnight. Okay, that was interesting. Really, the very next click was OS distribution, and it was only their Windows 10 tablets that were failing. We could see everything else was connected fine. We had them go validate. Hey, can you connect with your iPhone, your laptop, et cetera? They validated it. So we said, okay, well, sounds like there was a system change or some type of change specific to those devices that happened at midnight. Can you check with the device team? And sure enough, they had pushed out a certificate with an invalid date to those Windows 10 tablets. And it happened right at their change window at midnight. And within about 20 minutes, we solved that problem. We figured out what the issue was. They knew how to fix it. And that was their eye-opening experience. This was in the UK. They're a US-based company. They were about to put people on airplanes and fly them over. So the point of all that is when you have the data and when the data is presented in the right context, you can solve problems or understand the issues without having to be on site, without having to have a team of a full-blown network engineers, because the system is doing it. This is that 12th man kicking in. This is the unicorn, another unicorn plug, kicking in to solve problems so that you take that burden away from your IT staff. So anyway, that's a quick timeline to distribution on OS, but now you can see, okay, what were the failures across access points, any particular wireless LAN that we deployed, any particular manufacturer device, any particular band, all the way down. So we're grouping these failures in a way that's very logical, that helps me understand as I see them, here is the problem, here's the cause, and here's how to fix it. If we keep working left to right, you just see, okay, these are the actual affected devices. These are the actual clients that had a problem, and what their impact was on the scoring, what their failure rate was, what was the last AP they spoke to, what operating system were they running. Very powerful data grouped in a way that's easy to understand. And we also can show you the location of the failures. So this can be important, particularly if it's a RF related issue, maybe interference, something like that. It might be only affecting one part of the floor plan, not everywhere else. It's another piece to help us understand, does location have something to do with the grouping of failures? So it's an example. This is just showing you what is possible with the data. It's going to measure this across all of these different SLEs. So another popular one is coverage, and I'm back here to today, but I can go back to 7 days. Think of coverage. You go do wireless site survey, and you say, I want to design for voice quality coverage, neg 66, something along those lines. So what we say, okay, well, we want to design for that. So let's do the survey to make sure we would get that. And then let's put that in as a goal. Well, now we're just going to measure in real time how well we're doing against the outcome of the site survey, because the RF environment is changing constantly. So now we can measure that, we can see it. And you'll see later in the system, we actually do some analysis where we believe adding another AP in this particular area will benefit your goal of having neg 66 coverage, because things have changed. So again, it's that kind of closed loop feedback that allows you to say, okay, that's the problem. We're getting weaker signal than we wanted. Our suggested solution is putting another AP in this area. So all of that information is done and analyzed for you. So that's service levels. You can kind of get the concept behind how we use it to measure how well the system is performing over time in this location, et cetera. We do it for wired. We do it for WAN. If you're running our location-based service, we have it here. And then we have particular insights about any user, any location, where we kind of group the information in a way that says how well the system is performing. So anyway, that's one of my favorite things to start with, because you start to understand, hopefully, all this data that we're collecting, what AI does to group it so that you know how well the network's performing, what the user experience is like, and how you can solve for any issues that come up. A further iteration of how we leverage data is through what we call a virtual network assistant. So I've mentioned Marvis just kind of being the name of our AI engine. One of the ways we expose what the AI engine is doing on your behalf is through the virtual network assistant, VNA. Just kind of a couple of different ways it comes into play. The first is we do something called Marvis Actions. Marvis Actions is designed to really take it up another level, to say, if you come in the morning and you're sipping your coffee and this number is anything but 0, we've identified something where you need to take an action to improve, that will improve the user's experience. We've done all the work for you. The system has said, there's a problem here. Here's what we suggest you do to fix it. And here's who it's affecting, et cetera. So it's very prescriptive. When you think of lots of locations, or a school district, a hospital, a higher ed, a retailer, this is really impactful because it's doing the analysis for you without anyone having to be on site at the given location. So we'll break this down a little bit and I'll show you some examples. But Marvis Actions is one of our most popular ways that provides proactive measurements to say, this is an issue we've found, here's what you need to do to fix it. So from a layer 1 perspective, we're looking at things, in this case, like a bad cable. So we can see that this AP is connected to a Cisco switch. I mentioned a lot of times you may not be able to go full bore with a Juniper switch and and wireless at the same time. As much as we would love that to happen, doesn't always occur. So the idea here is I can look at this particular device. So this AP on this port, on this switch, has detected a bad cable. So now you know exactly what you need to do to fix it. And the efficacy of this data is unmatched. If we tell you there's a problem that needs to be fixed exactly that way. So you won't get false positives. If we don't have enough data, we may not make the indication. So you could argue maybe false negative, but once we've detected it, we're telling you what needs to be fixed and what to do. So on connectivity, we're tracking things around authentication failures. I can go in here and dig a little deeper. And we start to see some spikes in behavior. This is part of the anomaly detection that we're doing, 132% increase during this period of time. So this is telling you that, okay, I've got some issues related to authentication that are affecting these users at this location, similar to DHCP. I can just keep digging in to get the data. So here we see our typical response times and failures, and then we got a spike. So this is an indication DHCP may be running out of addresses, the server's overloaded, run down. But you can see this is a clear anomaly. It's a 357.4 increase in DHCP failures at this one particular time is triggered an anomaly. So imagine this running across your entire footprint and doing all of this analysis for you. When you get into the Mist cloud, you're really getting right to the root of the problem so it can be fixed. Taking all that guesswork out. You're not going to be going through logs of different systems. I mean, we are not ourselves a DHCP server, but we can tell we are in the DHCP path. So we know if responses aren't coming back, same thing with authentication, we provide all that insight because the access point in this case is in the direct path of the engagement between the user and the network. So because we have that data, we can tell you which aspect has failed, why, and how to fix it. And I will say we tie in everything I'm showing you here in the UI is API based. So it's very popular for our customers to integrate what I'm showing you here into their trouble ticket system. ServiceNow is a very big customer of ours. You saw that on some of the logo pieces, and they're an example where if you're a ServiceNow customer, we can tie this data directly into ServiceNow, and it'll generate a trouble ticket when one of these actions triggers. So that bad cable, that would have triggered a trouble ticket. It would have routed to the right folks at network operations, and inside the ticket would have been the same data that we show you here in the dashboard. Another good example is missing VLAN, one of my favorites. So if you are local forwarding, so the AP is talking to the switch, and the switch has the VLAN defined there because it's not being tunneled. It's being handled right there at the access switch. Well, VLANs become really important in that case because from a wireless perspective, we're going to tag that traffic based off how they authenticated or their role. And if that VLAN doesn't exist on the switch port, that traffic's not going to go anywhere. And it happens a lot. It's a issue with that. Now, again, you may be running RAPs on a Cisco switch or Aruba switch or someone's switch until the funding comes around where you get that panacea of wired and wireless with Juniper. If this were a Juniper switch, we could just add those missing VLANs for you. It would just be done. But in the case where you're running our wireless and someone else's switch, we can't make those changes. This is where that data gets really important. So you can look here, okay, on this switch, we have this AP talking to this Cisco switch here. VLANs 100, 200, 300 are missing on this particular port. It doesn't get more prescriptive than that. Now you know exactly what needs to be done to fix it. This is a difficult thing to troubleshoot otherwise if you've ever run into this in the wild, because the user calls and they're connected. So you go through all your steps to make sure they've wirelessly connected, but they can't pass traffic. It takes a while before you get to this conclusion otherwise. Now we're going to tell you exactly what the issue is. If this were a Juniper switch, we would just add those VLANs automatically. But in this case, you can see this AP is plugged into a Cisco switch where we don't have the right access. The idea here is we can tell you exactly what needs to be done to fix it. So to close the loop on my discussion about tying into a trouble ticket system is if this data were integrated into your trouble ticket system, when that ticket gets, when this has happened, we generate the ticket, we send this data into the ticket. So you get it as your email, whatever process you use to get tickets, that data is right here. So I can look at the ticket that came in and say, oops, I'm missing a VLAN on this switch, on this port, and here's what needs to be added. Well, I don't even have to log into the dashboard at that point. I can go right into whatever I'm using to manage switches or command line or whatever, add the switch, add the VLANs on that particular switch port, and you're done. So that's where it can be important to tie this system into other aspects of how you run network operations, because we can really streamline things. And this is something that can be solved without you even logging into the UI at all. That's a very popular one. That one, we've detected a lot of things. Same thing with the bad cable on a switch. We're collecting traffic on the WAN piece where you have, Juniper SD-WAN. We have persistently failing clients. This is a popular one. So you have a client that just keeps failing. Well, that's not something we want to keep generating tickets for. We want to say this is someone who's got the wrong credentials and they keep trying with the wrong credentials. So the point of that is it's really helping you streamline everything in terms of what's happening on the network. So this is Marvis Actions. This is kind of our single pane of glass of everything that we have visibility into at the network, grouping it in such a way where we've identified an issue that's affecting the user experience. Here's the issue. Here's what you need to do to fix it. And here's who it's affecting. So really powerful, all in one spot, single place to go, and you'll make sure the system is running. You want this number to be 0. And if it's anything other than 0, we're going to tell you what needs to be done to fix it. So that's one implementation of the virtual network assistant. The other one I mentioned is the ability just to type in questions. And if I'm not a network expert, I don't know what 802.1x is versus 802.11. I don't know key things related to Wi-Fi. I'm an IT generalist as a frontline help desk, for example. I have to know a little bit about a lot of technology. That's kind of my goal. So in that role, imagine being able to empower your frontline help desk with this type of information, and you'll see that they can just ask a system a question. So they get a call from somebody that says, hey, I had an issue last Tuesday. Well, then I can do everything as simply as, show me unhappy users last Tuesday. And the system's going to go through this, and we're going to run some different calculations in the background. So we found on December 13th, which was yesterday, we had one user on the network that was having a significant amount of issues. So now I've picked it up just by showing that one query, that one question. It generated the result that I wanted. I wanted to know who was having issues yesterday. So here's the user that's having issues. And by just clicking on it, you can see it's continuing to run through this troubleshoots. Now I can say, okay, here's what I found. Well, they had an authorization error. Okay. Let's click through that. Okay. So we can see that 100% failures on the 5 gigahertz band. It's client specific. So this is a good piece of information. It's not something that's affecting the entire network. It's something to do with them. So again, I have all these different ways to keep digging. I like to go into the client insights. So what you can see that it's done now is it's taken us all the way back to essentially the main screen. But now we're on insights. We're filtered for this user, and it kept persistent the date range that I asked about in the question. I asked about Tuesday. So here I am filtered for this user on Tuesday, and I can see everything related to why this person was unhappy. I mentioned the 150 states we track for every user. These are things we're tracking. Good, bad, and ugly. If it's a bad event, and we feel like a packet capture is going to help us get to root cause, which it will with an authorization failure. You see this little paperclip here. Any event that has a paperclip associated to it means we automatically took a packet capture. So we went in, we have a capture of that specific instance at that specific time for that specific user, kicked off by that specific reason. And we store it for you in the cloud. It's right here. If you have a Cloud Shark, you can actually click on this and it'll open up the Cloud Shark interface. And you'll see the packets right there without ever having to leave it. But what essentially it's telling us here is I can go now, and instead of sending somebody out to do a packet capture, I can just download what the system captured for me. Open it up. I've got Wireshark here, so it's going to take me in. But now I've got the actual capture. Now, when we do packet captures, we only do the headers and the timers. We don't do the data payload. You don't need it. But if you can think about what we just did here and how this could apply to you going forward, is you should never have to go send somebody out to do a packet capture again. The system will do it for you. And if you've ever had a needle in a haystack issue where you had to get a capture and you go out there with your laptop analyzer, you drag the person out of a conference room or a classroom and follow them around, tell them, go do what you did last Tuesday. Now that I'm scanning, it never happens. You get in the car, you're halfway back, you're on plane halfway back, another ticket comes in, hey, it happened again. Think of that problem going away forever. The system will take the captures for you and bind it for you in the cloud. So you've got that information now, it's stored for you. And you think about how we got to this point. We went from show me who was unhappy yesterday or Tuesday I got right in within about 3 clicks to a capture of why they're unhappy related to an authorization failure. It's very powerful. It's a way we use the data we're collecting to provide insights you can't get from anyone else in any other way. But there's within this Marvis piece, we can say where is somebody. We can say what's wrong with this site. But when I talk about the full stack of wireless and wired and SD-WAN, you can do application related things. You can say, what was wrong with Teams yesterday? And, if we all use Teams, there's never anything wrong with it, but sometimes there is. So what this has done at this point is told us, okay, it took this question that I put in and it said, okay, well, which application of Teams do you want to track? Well, this one's bigger than this one, so why don't we focus on Teams? I just click it. Here's a list of the top sites. Well, that's obvious. It's our live demo site. So here I am. I click on it. Okay, these are the list of all the people that had a team session last week. So I'll just pick one of our product managers. And here's one of their team sessions from 8 p.m. to 11, working late. And now I can see the path. This was the user, the device. This is one of the team session. That looked okay. Let's check the next one, see if they had an issue with Teams on the other session. But the point and the discussion behind it is to give full client to cloud visibility from the wireless to the switching to the WAN. And I can do this across anybody that was using Teams last Tuesday. These are all the sessions. So it's designed to give that visibility of client to cloud. And if there's an issue, if someone says, hey, Teams wasn't working well, if I have the full path of the traffic, then I can see whether they were, if it was an issue related to wireless, if it was something on the switch, if it was something in the application or the transport itself between the user traffic and the application. All right, well, this was kind of some of the key aspects of what I like to talk about in terms of day 2 operations. Everything you can imagine from a configuration standpoint is built into the product. All your different aspects of configuration and radius and multiple pre-shared key and switch templates and fabric, all built within the UI. It's all template based. So once you've built it, day 0, day 1 stuff becomes very simple. APs or switches get connected. They pull the configuration and they're up and running. I actually do maybe see a couple questions here. Your APs have an end of life. Go ahead.
Oh, I was just going to say the one I saw here is, do our APs have an end of life, or can they be used for multiple years and still depend on the security updates?
Yeah, so we have a traditional end of sale, end of life program. None of our APs have hit that yet. We would do an end of sale announcement, and you have 5 years after end of sale for before it would be end of life. So I think that would be pretty well industry standard. I should say that our APs, they talk and they send telemetry data to the cloud, but every AP has its own operating configuration on it, own software, own operating config. So if there was a break in connectivity between the access point and the cloud, you wouldn't lose any functionality because their APs run on a persistent configuration that they get. The first time they pull a configuration down, they're running with that last known config until they get something different from any changes you may make to update the config. Same with the switches.
And then a last minute question came in here. Does Mist and Marvis work with other APs, such as like HP, CommScope? I'm not exactly sure if they're kind of asking, can you kind of get that telemetry data like you were with the switches, as long as LLDP is turned on? Or
yeah, we get this question a good bit. Do you have to use Juniper Mist AP hardware to get this data? And the answer is yes. For a couple reasons. When Bob first built the company, the original intent was to be agnostic to the AP and just collect data from whoever's APs were out there. But it became pretty obvious as he dug into that we really needed our own hardware, our own AP hardware to collect and trust the data that's coming into the Mist cloud, because we're making decisions on that data. There couldn't be any ambiguity. about what we were receiving. So it became obvious very quick in the Mist journey that we needed to build our own wireless access points so that we could get and trust the data that's coming in to the Mist cloud. And that gives us that efficacy I'm telling you about, already mentioned with Marvis actions, or knowing if changing something in rate of resource management automatically is going to improve. That's a function of getting that data from the wireless access point. We need to trust that data. So we build our own APs is a long answer to a short question. So yes, to get this visibility, you run a Juniper Mist AP.
Another question here. How does Marvis and Mist handle firmware updates to Juniper switches as well as APs?
Yep. So every access point, every switch runs its own operating system, its own firmware, as we would call it. So there's a couple of different ways. We have golden versions of the operating system that can be deployed. All of our APs reboot in 17 seconds. So you push a new config out, or I should say a new firmware version to an AP, it's going to reboot. The switches are similar to getting closer and closer to quick reboot times. But the idea with the switches or APs is they run their own operating system. The pushing of that new firmware can be done in one time to all your switches, all your APs. It could be scheduled, it could be rotated, it could be some get it and they rotate through as they reboot. All those things, we put a lot of time and effort into how firmwares are managed across wired and wireless, so that you can always make sure they're running the right version of code. We actually track the versions that they're running to know that if you're running the correct version, compliance of this one switch is running a version that's not similar to the rest. But when a brand new switch comes online, for example, brand new switch comes out, when it talks to the Mist cloud, of course, it pulls a configuration, but it also pulls whatever the agreed upon version of firmware should be for a switch. It does that automatically the first time it boots up. So it's always going to have the right config, and it's always going to have the right software version running on the switch when it connects, similar to the APs.
And then the slide deck you had originally presented, is that available for any of the participants in this webinar?
Yeah, I have to scrub a handful of things, but I can make that available and share that. So if that content's helpful, I think one of the better ways to get more information about what we do is we have our Wired and Wireless Wednesdays, and Bytespeed has a specific link that they can provide. So you can go to the session. We do it every Wednesday. That's a full-blown engineering deep dive into the product for an hour long. You'll talk about all the config stuff I didn't talk about day 0, day 1, more detail about day 2, and you'll see a full-blown demo there. A lot of other customers will be on, so good to see questions going back and forth. Very useful. After that, if you want to pursue a meeting through Bytespeed, then what we'll do is go through and have that meeting with you. And by taking that meeting, you're eligible for a free AP. So it kind of works its way to get a product in hand to actually experience some of these things I've been talking about in your environment.
And on our website, just so everyone's aware, we do have the link on both the Mist and Juniper landing pages where you can schedule the consult or sign up for Wireless Wednesday. So it's readily available for all of our customers and anyone who's interested. One personal question I had, just because I'm a big comic book guy. Is it true how Marvis got its name?
As I understand it, it is true, where Marvis became an implementation of Jarvis from Iron Man, where Jarvis, you can ask Jarvis a question, and because we're Mist, it's an M, it's Marvis. Now, I don't know if Warner Brothers or whoever runs Iron Man comes asking, don't say I said that, in case they want a trademark kind of thing. Just kidding. But yes, as I understand it, the naming of Marvis was at least directionally aligned with what Jarvis does for our friend, or former friend, Iron Man.
Fantastic.
Well, thank you, everybody. Hopefully you'll take that next step, get into a Wireless Wednesday, or ask Bytespeed for a meeting. We'll do a very custom presentation for you. We'll do a custom demo based off stuff you see in the environment, stuff you would like to solve for, and it's a good use of time. And if it warrants, you can get a free AP after going through one of those meetings for you. But thank you, everybody. I appreciate the opportunity to talk.
Yes, thank you very much for coming to see how Mist AI is the unicorn of the networking world. And obviously, feel free to follow up with me on any other questions you may have. And have a great rest of your day.